So we're in free fall. We're going to say that downwards is positive. Downwards is positive. So we can solve for Vy final. Vy final is going to be equal to Vy initial plus GT. So we can say that this is going to be 0. And this will be the formula for Vy final. Y final is going to be equal to Y initial plus Vy initial t plus 1/2 of GT squared. This is going to be equal to 0. And this is going to be equal to 0. So we simply have half of GT squared. So if we were to graph this, we would have t here in seconds, and then we have v here in meters per second. And then it's saying model the first 5 seconds. So we can have 1, 2, 3, 4, 5. And then here we can have 15, 30, 45, 60. So it'll be 15, 30, 45, 60. Now, this, if the velocity is dependent on the time, essentially, the slope essentially is going to be the magnitude of gravity. So we can simply say that at 1, the speed is 9.8 meters per second. At 2, it's 19.6. At 3, it's just under 30. At 4, it's going to be somewhere, 4, it'll be somewhere around 40. And at 5, somewhere around 50. But the general idea is to get the shape of this graph. And the shape of the graph is going to be a straight line. Because again, velocity versus time graph in free fall should be linear, because the velocity is going to increase linearly with time. I apologize for the crooked lines, but this should be completely straight. And then for the distance, apologize. This will be, again, t in seconds. This will be y in meters. And then we can say we're trying to model all this 5 seconds. So it'll be 1, 2, 3, 4, 5. And then here we can simply say 30, 60, 90, 120. So I'll say 1, 2, 3, 4, 5. And then here will be 30, 60, 90, 120. So at 1, we have, it's going to be based on this. So at 1, we have like 4.9. At 2, we have 19.6. And then 3, we have around between 30 and 40. At 4, we have around 75 approximately. They're very rough estimates. And then at 5, we have a bit above 120, so 124 or something. And what's more important is the shape of the graph. And here, the shape of the graph, you can see, is going to be a lot more exponential. So because of that t squared term here, the graph here is going to be much more exponential and not so linear. So it's going to be much more exponential, and this is going to model more of a parabola than a straight line. So these are your 2 graphs, and again, the shape of the graph is more important than the actual values, because the actual values can just be found with a calculator. However, we're trying to realize why these graphs are shaped why they are, and here it's the v versus t in free fall will be linear. However, the displacement versus time in free fall will be exponential. And that is the end of the solution. Thank you for watching.